So now that we've talked about the six trig ratios that are associated with right triangles, both the SOHCAHTOA ratios and their reciprocals, right? We have SOHCAHTOA and we have CHOCHACAO, okay? Let's just work with one real basic right triangle here, okay? So we have our right triangle, we have theta. Remember that theta is the name of any angle, right? And we label the theta on the inside as opposed to the outside. Okay, so just things to keep in mind, different types of notation when we're in pre-calculus as opposed to a standard geometry course. Okay, so first of all, if we're going to start putting together some of these trig ratios, we need to indicate what are the opposite side, what is the opposite side, what is the adjacent side, and what is the hypotenuse. Well, we know that the hypotenuse is always pointed at by the corner of the right triangle square, right? So we know that this is our hypotenuse up here. And as far as this side that's labeled as 2, if you start at the angle in question, this is what I always say, and draw a line or an arrow or a dotted line to the other side, that's going to be our opposite side for angle theta, which means this is the adjacent side. And you'll notice that we don't actually have this measurement, right? So we would need to use the Pythagorean theorem for this. Right? Anytime you have a right triangle, okay, you're going to be able to deduce at least two pieces of information. And with those two pieces of information, you can figure out anything you want, right? So with these two sides, meaning any other angle or any other side, when you have two sides, you can always use the Pythagorean theorem. So if we use the Pythagorean theorem for this right triangle, okay, I'm just going to say capital A for now, might as well. And then we have the opposite side, the hypotenuse, which is 3. We end up with 4 plus a squared equals 9. A squared is equal to 5. So a is equal to radical 5. So I'm going to come over here and write that number in as radical 5. All right. Now, when we start to write these ratios, if it's okay with you guys, once you get this written down, I'm just going to erase this real quick because I want to have all this on the same screen for the sake of example. So let's start with sine. The sine of theta, right, is the ratio of the opposite side over the hypotenuse. The opposite side is 2. Sorry. The hypotenuse is 3. Now, at the same time, before we go on, let's talk about what the cosecant is. Remember, cosecant of theta is the reciprocal of sine. So once we have a ratio for sine, just take that fraction, flip it over. Okay, so even though I write this CHOCHACAO, right, it's just kind of here just to kind of get a little chuckle. Like SOHCAHTOA is at this point in your math career, junior, senior year in high school, you've heard this how many times, right? You've probably never heard CHOCHACAO. So I only put this up here because it's kind of fun to say. Really, when we want to talk about cosecant, it's best, and this is just my personal opinion, professional opinion too, I suppose, but when you're asked about cosecant, think about what sine would be, get that ratio first, and then just flip it over. Don't think about cosecant as hypotenuse over opposite, okay? Think about cosecant. When you hear cosecant, right, again, my professional opinion, the best way to think of this is figure out what sine is, find that ratio, find that ratio, sorry about that, and then flip it over, okay? So let's talk cosine. Cosine of theta is the adjacent side over the hypotenuse. That would be radical 5 over 3, right? And if that's the cosine of theta, the secant of theta is the reciprocal of this. Now, when we flip this over, we have a bit of an issue here where there's a radical in the denominator. And we're not really supposed to keep radicals in the denominator. So we call this rationalizing, right? And this happens quite a bit, actually, when we start talking about these reciprocal ratios, because not very often do we have 3 whole number side lengths, right? Those are the Pythagorean triples, which we'll talk about. But, most of the time, even if you have 2 whole number side lengths, the third one's not going to be a whole number. So when you start talking about reciprocal values, you're going to end up with radicals down here. It's best to just get in the habit when you see that, rationalize that denominator by multiplying it times the top and bottom. So we're going to have 3 radical 5 over square root of 5 times the square root of 5 is 5. So we're in a chapter, in a unit, in some territory here where you're going to see quite a bit of this, okay, where you have radicals within these fractions. Last but not least, we have tangent. Tangent is the opposite side over the adjacent side. So in this case, the tangent would be 2 over radical 5, which if we rationalize, we would end up with this. So we have 2 radical 5 over 5. And we know that cotangent is the reciprocal of tangent. Now, cotangent is the reciprocal of tangent. And yes, we did end up with this as our final tangent ratio. We don't have to flip this one over, because flipping this over is going to put that radical back in the bottom, right? This was the initial tangent value that we got. And to be clear, if you type this in the calculator and type this in the calculator, you're going to get the same answer. It's just they're equivalent representations. It's just that one's more a little bit, it is more mathematically acceptable, having the radical on the top. I can flip this value for tangent over and have radical 5 over 2. Now there's no radical in the denominator, and I don't have to go crazy with that. If I flip this over, right, I just end up multiplying times radical 5 again. Watch what happens. We get 5 radical 5 over. 5 times 5 is 5, right? So we'd have 2 times 5. These 5s cancel, and then you end up with this anyway. So I could flip it over. It's just creating more work. Take the easier of the two ratios, flip it over so that the radical stays in the top. Okay, and we like to express these as ratios, not as decimals. All right, so just leave these all in their fraction form.